students, you are welcome to the knowledge series on page replacement algorithm. Before I start this page replacement algorithm, let me give a basic awareness about what exactly is this. Now, as the name of the page replacement algorithms, it's one of the important topic in the operating systems. You have come across the page fault in my earlier slides. The page fault is the important concept, as we have discussed in the previous video series. There are different concepts behind this page fault. Normally, to understand this page fault, the basic and easy way to understand is this one, is that the memory is normally divided into two parts, main memory as well as secondary memory. Whenever a program is need to run and it need to fetch, assume that a process from the secondary memory to main memory, it is not possible that all the informations or all the data or all the process parameters can be moved from the secondary memory to main memory because of the limited size of the main memory. So there is a need for efficient swap up of the process or the data from the secondary memory to the main memory, so that the CPU can able to fetch and able to execute in appropriate manners. So based on this, the page replacement algorithm is going to discuss over here. And this is needed because if you want to increase the CPU performance as well as to improve the page hit, this algorithm plays a very vital roles. Page hit, when I say page hit, means whenever a secondary memory is transferring a file to the main memory, when it is received by the main memory, that is known as a page hit. And whenever the secondary memory from the main memory moves to the secondary memory, and the space that is being created, that is a page fault. Page hit means whenever CPU request for any pages in the main memory and it is already available, is called as a page hit. And if it is that means a page hit is already, page is there, but even if the data is moved and since it is available, that we termed this as a page hit. And if that page is not available in the main memory, then we call it as page fault. There are different type of page replacement algorithms. For your understanding, if you see the slide over here, FIFO page replacement algorithm, LIFO page replacement algorithm, LRU page replacement algorithm, optimal page replacement algorithm, and random page replacement algorithms. Now, FIFO, as the name indicate, first in and first out. In a FIFO, first in and first out page, that means whichever comes will to the main memory, it will go out. And this particular FIFO algorithms, when I will come across my next slide with respect to the numerical problem, you can see that it will replace the oldest page in the main memory for the whichever is available for the longest time. That means that page will be replaced by the new page which is coming, and it keep track of all the pages in a queue. That is the FIFO's page replacement algorithms characteristic. LIFO means last in first out. In this case, in a LIFO, the last one which comes to the main memory will be first going out. It replaces the newest pages that arrive at last in the main memory. That it means. and it keep track of all the pages in the in a stack. So that is the LIFO's specialities is that. LRU. LRU stands for least recently used. Now LRU is almost all like a FIFO. Only the difference is that when a page is hit, it will get a refresh from the memory, and after the hit, it will be treated as the fresh or the number one. It replaces the pages that has not been referred by the CPU for the longest time. So it is exactly, if you try to see with respect to FIFO, it is almost all same. Optimal page replacement algorithms. Optimal page replacement algorithms, as the name indicates, it is an important, but practically it is not possible. Hence, hence the future reference need to locate in this case. And we normally keep track of the initial pages, but the future it's a little difficult. But in this case, the page hit exists more often. So it is used for the performance measure criterion for other algorithms. This algorithm replaces the pages that will not be referred by the CPU in future for the longest time. It is practically impossible to implement this algorithm because the page that will not be used in future for a longer time cannot be predicted. That is what exactly I means, that initial pages is possible, but for the one which is for a later part, it is little difficult. However, it is best known algorithm and gives the least number of page faults. That is the speciality of optimal page replacement algorithms. And another is the random page replacement algorithms, and this algorithm is randomly replace any pages, and it behaves like a FIFO, LIFO, LRU, and optimal, etc. However, as per the syllabus and what I'm going to do is that I will be discussing in my subsequent slides with respect to FIFO, LIFO, LRU, and optimal page replacement algorithms using an example. Thank you.